We do all of our product testing here to identify the type of machine that's best suited for your application, to figure out the configuration and the accessories you'll need to hit the rate, the accuracy, and all the other specifics to your application that you're looking to achieve. Our sales representatives from there are going to take a look at your application and figure out if we're going to need to do laboratory testing to find the best solution for your application. The sales team will write up a lab request, and they'll submit it to the lab here, and what we'll do is we'll test your product when you send a sample in. The service is completely free, and it's just for the benefit of All-Fill being able to provide you the best solution for your application possible, and for your own peace of mind. Things that we request is at least a 5-gallon bucket worth of your product. That way it gives us enough product to really evaluate how well the machine's going to run. From there, we'll also ask for any safety data sheets regarding the product, so we can equip ourselves with the proper PPE to keep ourselves safe while we test your product if it's a hazardous product. What we'll do from there is we'll gather approximately 20 test weights to see what the accuracy is that we can achieve with your product. We'll evaluate any potential hiccups, environmental factors, other sorts of issues that are variables to us being able to run your product efficiently. From there, we'll take this information, sometimes we'll shoot video to give you video footage of how the test went and to see any issues that we may have come across. That way you can see it firsthand. We'll take this information, we'll compile it together in a report, hand that off to the salesman you've been dealing with, and then they'll get back in touch with you to show you the results of the lab test. Again, this is completely free service. We do it all right here in-house, and we have multiple different pieces of test equipment that we can run your samples on and evaluate it and get you some good results. So typically when you send a sample in, if it's a powder, we're usually going to steer towards an auger filler. Powders usually come in two different forms. We either have a non-free-flowing powder or a free-flowing powder. There's examples of both down here. And it's pretty simple and straightforward to tell which powder is a free flow and which powder is a non-free flow. We do get products that are in between, but just for demonstration's sake, this powder right here is a free-flowing powder. You can tell because if you aerate it, press your finger into it, it'll collapse on itself. The hole doesn't stay. With a non-free flow product, it's the opposite. So even if you aerate it, you can see this has like a fat content to it. When you press your finger into it, the hole stays. Now, depending upon the results of a test like that, that'll steer us towards what type of accessories we're going to use. We have different types of augers for different products. We'll make that determination here in the lab. With something like this, it's a free-flowing product, we'll use free-flow tooling. It consists of an auger, a cone collector, a funnel, and a few other pieces that we don't have out front here. So in the lab, once we determine if it's a free flow or a non-free flow powder, from there we'll take a bulk density test. So this is a free-flowing powder, so we've got some free-flow tooling here. We'll get to that in a minute. What we'll do is we'll take our graduated cylinder, take a sample of the product, take right about 1,000 milliliters, and we'll weigh that out. Looking at that, we'll do a quick calculation, and what that tells us is that this product is about 23 pounds a cubic foot. This gives us an idea on sizing the proper tooling for this product to dispense at rate and for the fill size that the customer is looking for. So when it comes to powder handling or fine granule handling, we can categorize this into two different sets of tooling, free flow tooling and non-free flow tooling. Now, like we demonstrated before, the free flowing powders will collapse on themselves and non-free flowing will hold a shape. Basically depends on how fine the powder is, the fat content of the material, the moisture level, a whole lot of different variables go into it. A standard free flow setup looks something like this. Let me pull some things out of the way. You have a straight auger with a threaded stud on the end, spinner plate, a nut to bolt the spinner plate to that auger, a collector funnel cover which can be vented if needed, a collector funnel, So we have a few different styles of these. And a straight funnel. Now the idea with a free-flowing tooling setup is it's a product that falls on itself. So it doesn't need to be forced out of the machine's hopper. With that, you don't need much agitation. So agitation is used to force a product to move and feed down towards the auger. With free-flowing products, it moves very easily down the auger. Hence the spinner plate. The spinner plate catches the product at the bottom of the flighting of the auger and keeps it from just pouring straight out in a steady stream. Now with that, some free flow products do need agitation, and this is our standard agitation plate. It's a slow speed agitation. And this can be used for free flow and for non-free flow tooling. Good free flow examples are grains, chia seeds, flax seeds, things like that. They will feed through the auger very, very easily. Now on the other end of the spectrum, you have a non-free flowing powder. Non-free flowing powder doesn't like to come out of the hopper easily. So with that, you have to have a self-feeding auger. And the idea behind the self-feeding auger is it's no longer straight like that last auger I showed you. You have a smaller flight diameter that actually feeds the product out the end of the discharge. But at the top, you'll notice there's an oversized, what we call overflight. That helps to grab product from inside the hopper and drag it down into the auger and feed product out the discharge. To aid in that, we'll sometimes add something called a D-blade, which is a high-speed agitation. Inside the hopper, there's a spindle or a shaft that this will lock into. This is mounted on the shaft above it. And what this helps to do is it spins with the auger. It takes the product surrounding the auger and helps push it and force it down into the flighting of the auger, delivering more efficient product flow. The funnel on the bottom, the main difference between the free-flowing tooling and the non-free-flowing tooling, the funnel part of it, is that there's a lip. You can see the small lip here. The other side is straight. This auger will ride inside. We'll create a small gap between the lip and the bottom of the auger. So this gives us better control over the non-free flowing product and allows us to dispense it easily. With some non-free flow products, what we'll have is as the auger becomes primed and packed with product, sometimes the bottom flight will fall out of the bottom. What we can do to limit this is add what we call a drip washer. We have various different diameters of these, and what it does is it adds additional surface area to keep this bottom flight from falling out of the auger. This is held in with just one screw right here in the center. Another option is to use what we call a grid restrictor. And these come in many, many different variations. Serves two purposes. With some fatty materials, sometimes what we need to do is actually condition the product to come out of the auger in finer particulates, rather than extrude it as one large piece. By forcing it through different grids, we can actually change the way the material comes out of the auger. This also works in providing more restriction than a standard drip washer would. All of these working towards eliminating a drip issue.